Okay, that's cool. That's cool. Yes, thanks for joining the webinar. And I know that's where it's already December, right? So it's already the last month of this year. So today I'm not talking about too much about whatever we done. Basically, I focus on our visions, RisingWave vision for 2025. Yeah, definitely there are a lot of, if you check our GitHub or check out the Malaysia website, you will know that we have already delivered a lot of features and so a lot of new features being built. But so in this talk, I talk more about the big pictures in 2025 about the Python, Iceberg, Bash mode, and AI, and probably many other topics. Okay. So, okay, one slide about me. I'm a founder of RisingWave Labs. So yeah, that's it. And what is RisingWave? So if it's your first time to get to know us, then RisingWave is the distributed SQL streaming database, and it's essentially a best-in-class. We are pretty much focused on stream processing, management, and analytics. For example, you have these data events coming from, let's say, IoT devices, or coming from the let's say, stock market, or coming from certain kind of like website, right? So it's event streams, and what we do is to help you to process these event streams, manage them, and do perform analytics on top of the event streams. That's what we do. And so RisingWave was open source in actually almost 3 years ago, and it's under Apache 2.0 license. Right now, it has already been adopted over 1,000 companies, from startups to Fortune 500 companies, or even actually some of the Fortune 550 companies. So, so what about the verticals? So you know that for stream processing is pretty, I mean, it focuses on event data, right? So what kind of like services, or what kind of verticals have the event data? So we pretty much see that for our customers and the users fall into several categories. One is the financial services, like payment services, fraud detection. They probably want to check, okay, I'll check the person's credit, right? And in terms of, and apart from the payment services, we actually have a lot of users and customers coming from the capital markets, such as brokerages, hedge funds, trading firms, and many others, right? Why they need to have stream processing? Because of they have the order book, or they have the order management system, right? And they also need to real time compute, well, the check their compliance in real time, and they also want to do the real time risk control, right? They probably also want to do the portfolio, calculate their portfolio positions in order to make sure that they are in a good position, right? That's about the capital markets. And apart from the financial services, we do see a lot of customers coming from the entertainment industry. Entertainment industry includes gaming, includes sports betting, includes publishers, and includes many more, right? So in terms of gaming, you can just imagine that, well, if we play online game, then definitely the game publisher really want to have, let's say, have a real-time user engagement session with the player, right? Well, in order to basically encourage the players, right? And in sports betting, they calculate the risks, right? Because, well, I mean, betting is always pretty risky, right? Well, and you always want to make sure that, well, you are in a good position. In publishers such as the news network, right? Well, they have the website, or they have the or even they have the Twitter, right? Well, they actually want to place the news and on their website based on the popularity of the news, or based on the viewers' reactions. They probably sometimes will also change the titles based because of the users' reactions. Yeah, so that's everything is happening in real time. So that's the entertainment industry. And regarding the e-commerce, we actually found that for the AI, right? What many people talk about AI, and we find that for the AI essentially give a boost to the e-commerce industry. For example, personalized recommendation, right? Where in the past we probably can, do recommendation based on, yeah, algorithm, right? Well, our algorithm, our the engineer's algorithm, certain kind of algorithm. But nowadays, what we find that people essentially use AI to do the recommendation, right? Well, basically, they actually ingest all the prompts into the AI and the LLM, and the LLM can generate the recommendation to their end users. That's what we see. Though that's not what we do, but that's what we see in that many of our clients actually do that for price comparison. So it probably more classic use cases. Basically you have so many websites and essentially people really want to collect the price data from different websites in order to make sure that the price is appealing, right, to the end users. Fraud detection, also another big use cases in churn prevention and prediction, right? It's also a pretty important use case in e-commerce companies. So what about the other sectors or industries? We do see that for energy and manufacturing are pretty popular. And because for energy, you probably really want to calculate your energy consumption, or probably want to detect the anomalies, right, in your pipelines. And for manufacturing, I think it's some roughly the same, right? And for logistics, it's more about order management, right? We have so many packages and how we can ship this package from one end to the other, and we also need to check the inventory in order to manage our inventory smartly, right? So okay, so that's RisingWave, and typically I do not really compare RisingWave with a specific product or especially a commercial product. But what about the open source? Well, we do see that in the open source space, we do see that probably 60% of the new users compare RisingWave with Flink, or probably sometimes we do see Spark Streaming, while the 20% of the customers will compare the RisingWave with K2DB. Well, we do see that these are all open source, but we do not really talk about the commercial product. And we do see that some of users compare RisingWave with Postgres. So then how RisingWave is different from the other stream processing systems, no matter whether it's Flink, Spark Streaming, KCDB, or whatever, right? So how do we do the comparison, right? Well, I mean, we probably before talking about the detailed comparison, we probably can talk about a little bit about the design principles. RisingWave design principles include 3 parts. The first one is that we are Postgres-style, Postgres compatible, meaning that we really want to deliver the Postgres-style experience to the users. So that's why if the users have already adopted Postgres, they have a pretty smooth transition from their Postgres to RisingWave. The entire experience, though, is a streaming experience, right? It's no different from their conventional like Postgres experience. That's number one. And second one is about the cloud native. We know that a lot of customers are nowadays using cloud, right? And many startups, so probably some AI companies, rather from day one, they are in a cloud. So they want to make sure that everything is in cloud, and they want to make sure that we can achieve the cost efficiency in the cloud, because the cloud environment is totally different from the on-prem environment, right? So from day one, RisingWave is designed for the cloud, because we actually adopted the so-called S3 as the primary storage architecture in order to make sure that the price or the cost efficiency is always the best compared to any other designs. And the third principle is about all-in-one, which means that it doesn't really mean that we want to do everything, but it means that we do 3 things. We focus on 3 things. One is stream processing, the other one is streaming management, and the third one is about streaming management and the streaming analytics, right? So if you use certain stream processing systems such as like Spark streaming, you probably need to think about okay, how to get a database to serve your. Need to worry about that because RisingWave can serve the results, can serve your queries, and can essentially manage store your streaming data in there. So inside of RisingWave, so it's all in one. You do not need to bring in another database system into your streaming data stack in order to serve the data. No need. Okay. So okay, there's one question. Saw your tweet about leveraging AI and pretty okay. And so yeah, we were definitely talking about AI after because right now we are just doing a pretty quick intro about what the RisingWave is, and we will talk a lot about AI in the following slides. Yeah. Okay, so then why RisingWave? So definitely there's ease of use, cost efficiency, fault tolerance, and dynamic scaling, right? And I will just give a pretty brief introduction about all these features, right? All these properties. Yeah. So about the ease of use, there's no manual state management. If you use no matter whether it's Flink, EasyDB, Spark Streaming, whatever, they do require you to manage the states, right? Well, that's pretty painful. You probably have no idea about how to configure RocksDB, right? In RisingWave, we have our own cloud native storage, so that we do not need to manage the state in our own. And the other thing pretty important is that it helps you to simplify the data stack because, I mean, imagine that you are using a certain stream processing system. No matter what kind of stream processing system you are using, you probably have to have a Kafka topic sitting in between the two different streaming jobs because, I mean, the streaming processing system, the instances may not be able to directly talking to each other, right? But in RisingWave, there's no need to have Kafka sitting in between two different stream processing instances. You can just build a materialized views on top of another materialized view in order to guarantee that, in order to process a pretty long data pipeline, right? Okay, and about the PostgreSQL, I probably don't really need to talk too much about that, right? I probably can give more time about talking about the AI Iceberg and some other stuff. About the cost efficiency, I just mentioned RisingWave is like using S3 as the primary storage, so that you do not need to worry too much about the state size. You do not need to worry too much about the how to tune the states, right? And because all the entire states is stored in S3, and which means that it's cheap. So and we do also definitely do caching. S3 access is pretty expensive, but we do the caching so as to ensure that the performance isn't the cost, the S3 access cost is good enough, right? So it's reasonable, right? So S3 is the primary storage. So this architecture also help us to achieve two things. One is second level failure recovery because second level fault tolerance, which means that once your single node, one certain node failed, you can immediately recover from the failures. Why this can happen? Because compared to because we're in RisingWave, the state is essentially maintained in S3, and you can directly load the state data from S3 without rolling back to the previous checkpoint. But in traditional stream processing systems, it's like, okay, you have to, so once a single node fails, you actually have to go back to the previous checkpoint and do the recovery, do the recomputation, right? Which can be very time consuming. And it's essentially the checkpoint reloading phase could be very expensive. Think about if you are doing complex queries like joins, and your the join state size could be huge, right? Well, probably terabyte, right? We do see that in some very complicated use cases where it has the tens of terabyte or even bigger state, right? Reloading the state from reloading a checkpoint from this S3 could be very, very time consuming. But in RisingWave, there's no need to do that because the state can understand the data format so that it does not need to reload the entire state. So about the dynamic scaling, it's similar. And so instead of if you want to scale from one machine to three different machines, you do not need to reload the checkpoint. The only thing you need to do is to scale out because for all the three newly created machines can reload the state from directly from S3. Okay, that's the design. So about the popular features in 2024, right? So we developed so many features in 2024 and actually also even before 2024. And what are the popular features in RisingWave? So definitely I cannot just go over every single features because I believe that every single feature is important. But we do see that a few features are pretty it's pretty attractive to many of users. Yeah, one is the DBT integration, right? RisingWave actually have 20 plus or even probably 30 plus source and sink integrations, which means that it can directly integrate with your the Postgres, MySQL, MongoDB, or S3 or Iceberg or whatever, right? They have such kind of integration, and you can also sync the data into the data lake, right, or data warehouse into some other places. But DBT integration is really appealing because it helps people to simplify their logic, right? So think about if you want to write the different materials view, tens of materials views, then if you want to write the materials views from scratch, bro, then you actually need to think a lot about how do you want to model this data materials views, right? But using DBT, they actually helps you think to simplify the data modeling because the only thing you need to do is to write about the logic, and the DBT can handle the modeling for you, right? That's the magic from the DBT, and we found that DBT integration is really appealing to many of the users. The other one pretty interesting type of queries for users is time travel queries. So in event streaming use cases, people probably want to check what happened in the past, right? What happened yesterday? Especially think about the stock market or think about or even IoT devices, right? You probably want to understand, okay, what happened yesterday at a certain time point, right? We want to check, okay, whether all all the kind of metrics at that time. How can we do that? In RisingWave, we do provide a query, a functionality called a time travel query, which means that you can directly tell the system, okay, which time point you want to travel back to, right? So you can just use select a star from historical table for system time as of a certain timestamp. With this query, you can essentially go back to the previous time point and understand, okay, what happened there, do all kinds of the analytics, right? And we do see that with some users also do branching from that point because they probably want to do some other modify some logics there, right? That's pretty interesting feature if you especially if you are in the financial services or payment services fraud detection spaces, right? There's a pretty interesting question. So does RisingWave use Apache Iceberg as the default storage format? And yeah, so I will talk about that after it's like that. Okay. Okay, and the other pretty popular feature of RisingWave is the S of join. S of join is pretty critical in the time series use cases, right? Think about the stock market and think about the IoT devices. You probably want to join two different data streams and to align the timestamps, right? So that's what you want to do, right? So essentially, RisingWave Pro supports two types of the S of joins at the moment. One is the inner S of join, and the other one is the outer S of join. We are actually implementing more features around the S of join because for the financial services and IoT devices, or IoT companies really rely on this functionality to do the data analytics. That's pretty important. So, and the other cool feature in RisingWave is the UDF, right? So we do support UDF, UDAF, UDTF, basically the user-defined aggregation function and user-defined table function in RisingWave. What we did right now is that we essentially, yeah, some of the users host their UDF services, right? But essentially, you have another option. That is the embedded UDF. You do not need to create a UDF service, which could be costly, right? Because well, anyways, we actually need to maintain an additional service. But RisingWave does support for the embedded UDF services, so that you do not need to create a different independent service for the UDF for the UDF functions. Right. The syntax is also pretty simple, right? Well, you can just create a function called a function name, and okay, and identify that for the language is Python and S, right? So basically, this is pretty straightforward, and I believe that's really if you Redshift not Postgres, but well, Redshift Snowflake users, you can you also know that well, you can also do the same thing in these systems, right? In RisingWave, you can do this natively, and you can use different languages like Python, JavaScript, and some other languages. So let's talk about the focus of RisingWave 2025. Our focus is includes several pieces. One is a feature enhancement. The other one is Python, and the third one is Iceberg. Yeah, we were cover the question about the Iceberg table thing, right? And then it's batch mode. And the last one is AI, right? Well, because AI is it's pretty exciting, and a lot of people ask us, well, what's our AI strategy, right? And whether we support text to SQL, those kind of things, right? So I will give you an answer here. So about let's talk about the feature enhancement, right? Well, I do believe that's where there are a lot of like cool things we can do, but let's talk about the feature enhancement. What's the top features we are building at the moment? So the key feature we are building at the moment, I believe is if you ask me just one feature that we are building, or in trying to enhance at the moment, well, then I would like to say that is the isolation. Isolation is pretty important because we do see that in some large organizations, they actually have so many different data teams, and we really want to do everything inside of RisingWave. We have already seen this use case in the financial service, insurance companies, manufacturing companies. They actually have different teams and operating in RisingWave. They don't really want to have so many clusters. Why they don't really want to have so many clusters? Because they want to have the data shared across different instances, right? Shared, all can be controlled, right? Can be shared across different teams, right? How do we do that? If you just rely on one single RisingWave instance to do that, well, then the challenge will become that potentially, at least in 2024, early 2024, potentially there will be some problems. That is performance interference. Let's say that in some other teams, they have they create a pretty big streaming job. What we can do? I mean, some other teams' performance could be dropped, right? The streaming job performance could be degraded, right? So that's pretty painful. And so we do introduce we are working. We have already been working on isolation for over a year, and our focus will include three pieces. One is the fault in the isolation, and the other one is performance in isolation, and the third one is functionality isolation. In terms of performance fault isolation, let's talk about fault isolation. Fault isolation means that, let's say that one single streaming job failed, right? One of your job pipeline, streaming pipeline failed. Then whether the failure can interfere with can affect some other streaming jobs. Last year, yes, I have to admit that. Yeah, last year, yeah, there'll be some effect. Well, a job failure can affect some other jobs, but this year, no, it will not affect because we have already had done the fault isolation. So basically, if one single streaming pipeline failed, because of all kinds of reasons, right? Bad code, probably bugs. I hope it's not, but bad code and probably just about all the memory, right? If this job failed, it will not affect some other jobs, right? That's number one. And let's talk about the performance isolation. For performance isolation, the thing could come that okay, let's say that a team create a pretty big job, right? Or whether it can affect some other team's job, right? So we have really we have been working on performance isolation over a year, and within the next probably 30 days or at most 60 days, well, we will have a performance isolation, which means that you can essentially control, you can essentially explicitly isolate the performance of two different jobs. You can tell RisingWave that, okay, no, for this job, I only want to isolate for the certain, I only want to allocate, let's say, 4 CPUs. And for that job, I probably only want to allocate for, let's say, 8 CPUs. Even if in a single, if these jobs are in the same instance, we can guarantee that their job performance is isolated. That's what we're currently working on and will be delivered pretty soon. And then the other feature is called functionality isolation. Functionality isolation is different. It's a little bit different from performance isolation. So recall that in RisingWave, we do support stream processing, and at the same time, we also support streaming. Basically the data serving. Basically, it can serve your results, right? Well, it can support what it can capture serving. Let's say that you have thousands of point access to RisingWave matrices. We do support that. And RisingWave functionality isolation means that it essentially isolates a streaming processing node from the streaming serving node, the data serving node, so that you can scale out your serving node independently, right? Well, and this feature we have already this feature has already been delivered in RisingWave, and essentially many users have already used that. But we do believe that this feature needs some highlight, and definitely we are trying to further enhance this feature because in many use cases, once people want to serve the queries, right? Well, it's especially they want to replace their Redis service, or if they want to replace their DynamoDB service. We do really want to make sure that the RisingWave performance and the stability can compete with this feature with these services. And we have already delivered that, and we will definitely continue to enhance the features. So that's about the isolation. Then let's talk about the Python SDK. Python SDK is very important for us because, well, I mean, we are living in an AI world, right? Well, I don't really want to always talk about the AI, but I have to admit that we do see that many people are coming from the AI world, and they told us that, well, okay, they want to call the OpenAI API, or probably they want to use the pandas, or they want to, yeah, they basically the rest of the code base is in Python. How RisingWave can be integrated with your Python, basically the Python ecosystem, right? So in the past, we rely on the Postgres Python library to do the client, right? To be integrated with their customers, the Python ecosystem. But what we have already delivered in the last quarter was that we delivered the Python SDK, which means that you actually have the native Python SDK in RisingWave. And this is just real code, right? Well, and you can just connect to RisingWave instance using Python instead of using the Postgres client, right? And the most interesting thing I really love about all Python UDF is that or SDK is that you can actually have the so-called data frame in and data frame out experience. You can just insert a data frame into RisingWave using RisingWave's Python SDK, and the Python SDK will return if you call a function, right, to execute, it will all the own change. I can talk about the own change later. It will return a Python the data frame so that you do not need to do all these kind of boring transitions, right? RisingWave can handle that for you. And as a stream processing system, one feature of writing without has is that it can emit the signals, right? So let's say that you do some, let's say, complex event processing, and you identify the fraud, let's say in fraud detection, you identify a fraud, right? Then how do you notify the client, right? How do you notify your Python program, right? In the past, probably you need to write a SQL, which is good. Well, I mean, which definitely, yeah, you can also definitely do that. But right now, we have another way to do that. That is where you can just use call the function called in Python. You can just call the function called RisingWave.onChange. So that's where it can emit the signal for you, right, for directly to your Python library, so that you can process the rest of the logic in Python. And we do notice that in the gaming and in some other or in e-commerce industries, they actually require us to implement the JavaScript SDK. And yeah, I do agree that is pretty important, and that's on that's definitely on our roadmap in 2025. So yeah, data frame experiments, and let's talk about Iceberg. So RisingWave can directly support Iceberg sync. So which means that let's say that if you have Postgres or if you have MySQL, if you have a MongoDB or whatever, right? You can continuously sync data from your your operational database to the Iceberg, right? We just using the statement called the create sync statement, which is pretty powerful. But we want to and at the back, so under the hood, we actually have our own so-called the Iceberg Rust interface, which means that we do not really go through the Iceberg Java interface, which could be slow, and we directly go through the Iceberg Rust, which is Apache Foundation project. And we directly go through the Iceberg Rust interface, which can achieve 3 times plus performance improvement compared to conventional Rust interface, which is pretty powerful. But this is what we have already done last year. But which is pretty interesting in what happened in 2025 is that we were introduced another big feature called the Iceberg engine. So right now, all the data stored in RisingWave is essentially stored in row store, which is called the Hammock. You can just think Hammock as like a cloud native RuxDB. Yeah, we implemented from scratch. It's nothing to do with RuxDB, but yeah, it's a LSM tree based log structure merge tree based cloud native storage, and it's row store. But we do see that people want to use Iceberg. Everyone know that, right, how powerful Iceberg is, right? So in 2025, in Q1 2025, actually 3 months is from now, or probably even just 2 months from now, we will deliver a feature called the Iceberg engine, which means that whenever you create a table, let's say no matter whether it's like from Postgres, from whatever, right, from your Kafka, no matter where the data comes from, RisingWave can just create a table, can help you to persist the data in Iceberg format. It's native Iceberg format. So it's not a syncing into Iceberg. It's just like an Iceberg table inside of RisingWave. So go back to the previous question about the time travel query, whether it's stored in Iceberg format. Well, if you have the Iceberg engine and you tell RisingWave that look, this table format I want to store, at least for this table I want to store in Iceberg format, you can just declare that the engine equal to Iceberg, so that all the data will be stored in Iceberg format, right? So in here, well, so it's like, okay, storing a data, storing a table, in Iceberg, right? But in the future, probably we will also consider storing data in some other data formats, right? But like Delta, we know that well, Delta is like also kind of popular, right? And also probably some other interesting open data format. So what it means to RisingWave, it doesn't just mean that okay, we have the column storage, which is pretty cool, right? Well, and the column storage can definitely help us to accelerate query processing. And we do see that well, with the Iceberg engine, our columnar storage could be super powerful. Could be yeah, the basically the long run scan performance could be very impressive. But it also means that we can actually have the data, have your data engine, no matter whether it's pandas, right? Python, right? And Polaris is also Python library. DuckDB, Spark, ClickHouse, Redshift, Trino, Snowflake to directly query the Iceberg table stored in RisingWave. So that RisingWave is more like okay, the of yeah, yeah, Iceberg engine, right? Well, all the engine sitting on top of Iceberg. Everything is like, yeah, everything is around Iceberg. So, okay, so there's a question. Right, Iceberg is a storage engine. So how does it impact the role and adoption of RisingWave's native storage engine Hammock? So, like, well, for Iceberg and the Hammock, well, they are different in that, well, Iceberg is essentially the column store, while Hammock is a row store, right? Well, and you know that for this row store is totally different from the column store. We do see that well, if people want to do the point access, then they actually need to have the columns row store, right? Because well, they probably want to replace their DynamoDB or they want to replace their Redis. It's possible in RisingWave using the Hammock, and the latency is like a single digit millisecond latency. Well, in the past, with just a hammock, RisingWave could not serve the overlap queries pretty well, right? Well, let's say that well, you have, let's say, a long run scan, right? To scan the entire table and to calculate the aggregation or to join two different tables, right? What will happen? So in RisingWave, it could be slow because well, the row store, you know, that's what row store is always slower compared to column store in terms of the scan performance, right? But with Iceberg table, it totally changed the world because well, it means that well, within RisingWave, the data can be stored in column store, and more importantly, it can be accessed by any engine you need, no matter whether it's RisingWave. Yeah, you can just use RisingWave native engine, right? Or RisingWave native engine. That's where it's as well. It's the performance is get luck. I have my own engine like DuckDB, right? Well, for example, if you want to do embedded and analytics, you probably want to use DuckDB. It's fine. You can just use it. And you can just tell the DuckDB, okay, where the iceberg is, right? Well, where the iceberg table is, and to access the data. So so that's why column storage is the iceberg table engine is so powerful, right? Um, yeah. So that so yeah, it's pretty powerful because essentially early last year we found that we were thinking about like where we want to build our own engine, but it turns out that well, once the own column storage, but it turns out that well, okay, Iceberg is eating the data world, and it doesn't really make any sense if we do not really adopt Iceberg, to be honest, at these days. Will compaction be managed in the Iceberg engine? Yes, it will be managed by yeah, that's true. Yeah, the compaction will be directly managed by RisingWave. So yeah, and I know that well, in some companies, well, it's like they have already have their own Iceberg the table, right? Well, they have already have their own, let's say, Iceberg catalog. And how do we do that? So like well, in RisingWave, you can directly explicitly mention that well, the table is stored in Iceberg format, right? But if you don't really think that well, okay, the table should be managed by RisingWave, no worries, you can just use the conventional mechanism called create a sink. so that's where you can sync the data out into your Iceberg table. So basically, the all into a table that is managed by you, right, or by your organization. So yeah, this is just like a choice, right, between whether the table should be managed by RisingWave or should be just like, okay, managed by your own organization, right? That's what that's a trade-off, right? So managed by RisingWave, there are definitely pretty good features for if the table is is managed by RisingWave. So think about one big missing feature in Iceberg nowadays, in 2024, is essentially a CDC, which means that basically the data changes, right? How we can capture the data changes of Iceberg. Let's say that we have that long pipeline, right? Well, how do we capture the data changes of Iceberg? At the moment, there are actually no solution. Unless we use Spark, where there's a pretty tricky solution using Spark. But it's not efficient at all because Iceberg doesn't really expose its CDC to the external engines. So, but with RisingWave can serve as your CDC engine because it actually captures the changes. So it can capture the changes. But essentially, I can tell you that in 2005, Iceberg will introduce its own CDC service in so-called Iceberg Spec V3. And in V3, which will be launched in I think will be launched in Q1 25. Once the Iceberg CDC is exposed, every single engine in the market have to follow trend and have to find a way to consume the Iceberg CDC, right? And RisingWave at the moment is actually we are closely looking at the spec, and once it's implemented, and you will directly find that RisingWave can consume the CDC from Iceberg, so as to further build the pipelines on top of your Iceberg tables. And about for the batch mode. So RisingWave is a stream processing engine, but once we find that in some very complicated use cases, we find that not all the tables are frequently updated, right? They told that okay, they do have some very complicated tables that are frequently updated. The fat tables, right? Well, it's frequently updated, but there are some tables that seldom updated, right? Like some dimension tables, right? And let's say that if we want to build a materialized view on top of two-dimension tables, right? It doesn't really make any sense to change them in streams, right? Because of batch computation is good enough, right? And there are some use cases say that there are some use cases say that, okay, in this pipeline, I really want to have second level latency or even millisecond latency. But inside some other pipelines, I don't really care. Probably could day level latency. It's good. How do we do that? Okay, RisingWave will introduce a mode called a batch mode, which means that all the data will be computed, all the materials will be computed in batches. So that it can minimize, basically it can buffer the data so as to minimize your computation consumption, right? Because if you do the event-driven architecture, it always, could consume more resources because it's always on, right? But if you don't really care about the freshness, then we can definitely do computation just once every single day, right? But it's lazy computation, and it's more can save the cost, right? Okay, then let's talk about AI. AI to databases. What's the relationship between AI and databases, right? Well, let's just ask ourselves. Okay, what's the relationship between AI and database? Definitely, you can say that okay, we can do text to SQL. It definitely makes sense. Well, I mean, text to SQL is pretty important, and real-time AI workflow. What's your take on that? Okay, yeah, we will talk about for the AI part, right? Or AI workflows. So let's talk about AI. Yeah, text to SQL is definitely pretty important, and we do believe that every single database should have a text to SQL functionality. But I have to say that text to SQL is definitely not a focus of RisingWave 2025 because it's like we believe that in 2025, the text-to-SQL is just a commodity, and every single database should have that. And we do work with some text-to-SQL vendors to support for the to perform the text-to-SQL inside the RisingWave. And more interestingly, if you are Anthropic user, you will know that when Anthropic just launched the the Model Context Protocol, right, for the MCP, and you will find that RisingWave can directly talk with the MCP because RisingWave is essentially Postgres compatible. So we actually view AI more than just a text to SQL, and we want to segment. We actually want to put the database or RisingWave with AI into three buckets. One is the AI application, and the other one is AI components, and third one is the database itself. So the database. Let's talk about the database itself, right? Well, RisingWave is the database. And what's the challenges RisingWave face? When RisingWave users face, right? When using RisingWave, there'll be actually a lot of like I would like to not call it like a challenge, but it's definitely a usability issue. For example, let's say that your user have their Postgres or have their, let's say, Kafka. How do we connect the data, connect RisingWave into your existing data system, right? Well, no matter whether it's Kafka or it's like or it's like Postgres, right? Definitely setting up the source and destinations will be challenging to some beginners, right? Because they have no idea about why I need to set up all these parameters, right? So AI agents, we will definitely introduce AI agents to help the customers to set up the source and destinations, right? In stream processing, a big challenge is about the schema evolution. Schema can change, right? So we actually have to capture the changes, right? And how do we do that? Well, right now, many people, if you do not really have the, let's say, the if you're a Kafka user, if you do not really have, let's say, confluent registry, or right, well, you don't really know the schema, right? And if the schema changes, you don't know, right? We actually want to have the AI agent to help us to lift the schema for the users so that the users do not need to control the schema on their own, right? Because let's say that I get a JSON, what's the schema of the JSON, right? AI can do a pretty good job. We have already tested it internally, and we believe that's why it's a game changer in terms of it's probably not a game changer, but it definitely helps to improve the usability a lot. Especially in cases where the schema can change frequently. Spikes, right? We actually want to understand, okay, why this can happen. And we want to understand, okay, whether the progress was like, what's a freshness, right? Right now, we can actually do, basically, you can just use observability tools, right? RisingWave itself provides that. And you can also have the of the clusters. So the other thing I want to, okay, so that's about the databases and or AI for RisingWave, AI for RisingWave, and then let's talk about the next thing that is for the AI the RisingWave for AI components. One of the things we found is that people ask us whether we support vector search, right? We do not really have the vector search support at the moment because we found that they are pretty good for solid use vector databases like Chroma, Pinecone, Milvus, and many others, right? Instead of supporting our own vector search, we decided to we decided to collaborate with all these vector database vendors so that people can essentially use, or even PG vector, right? People can directly use the vector search functionality in those databases without exclusively creating a new instance there. So that's what we do, basically a deep integration with the vector databases. And also let's talk about then some people say that, okay, look, in a data stream, right? Well, I use RisingWave to do some computation and I generate some results. How can we enrich the data via LLM? It's possible. It's one use case is that, well, let's say we have the Twitter streams, right? People can we do see that in some, let's say, crypto companies or in some, let's say, stock trading companies, they actually use the sentiment data to basically to identify a signal, right? Potential signals, right? They actually do not really train their natural language processing model, right? Well, they directly use the LLM to do that. So how do we do that in RisingWave? Right now, what people does is that people use the RisingWave UDI function and the Python UDI function and use Python UDI function to send the request to the OpenAI API. It works. It definitely works, and we do believe. Yeah, I can confirm that it's not just a synthetic application; it's a real world application. But we do find that in the future, we want to support in 2025. We want to support on embedded functionality to directly call the OpenAI API, or the actually LLM API. Yeah. And okay, then let's talk about the last thing is about the RisingWave for the AI enhanced applications. In some application domain, in some verticals, AI definitely help a lot. For example, e-commerce. For example, the fraud detection, payment services, right? In the past, people actually need to write rules to detect the frauds, but in the future, actually not in the future, but in the AI world, people do not always need to write a rule on their own. Some people we do see that some people actually rely on the AI to write the rules for them, right? But it's a rule-based engine, and the people write the rule for them. And we have already talked to this kind of customers and told them that we RisingWave in 2025 will support editing the rule using the AI directly inside of RisingWave. And then there are some other pretty interesting use cases, such as customer engagement, right? In customer engagement, people actually want to for example, the bot, right? AI bot. People want to detect the user behavior to analyze the user behaviors and detect, okay, what kind of actions I should take, right? As a bot, what kind of actions I should take? Should I just give a description of this item, or should I compare this item with some other the items, right? Or similar items, right? So we do see that these customers have really, or these e-commerce companies have already started using AI to improve their user experience. And in RisingWave, we will have a pretty much better user experience in supporting these kind of applications. Yeah. So yeah, that's about the RisingWave plus AI. So if you talk about the RisingWave and the AI workflows, we do believe that RisingWave and for this feature, offer embedded functionality to call the OpenAI API can help the users to directly orchestrate the AI workflow, right? So basically, you have your data workflow along with your LLM workflow or the AI workflow within a single RisingWave instance. Yeah. Yeah, all right, yes, we are almost running out of time. So to summarize for RisingWave, we were planning to release RisingWave 2.0 in the middle of 2025 to make RisingWave much easier to use for data streaming applications. And we focus a lot about feature enhancement, Python, Apache Iceberg, Bash mode, and AI in 2025. All right. Thank you. Thanks, everyone. And if you have any questions, just reach out or just join our Slack committee. And I'm always there and happy to answer any questions.
Yes, thank you, everyone. If there are no further questions, yeah, we can wrap this up. Thank you.
All right. Thank you.